graphs of linear equations. It's going to be a short lesson, which I think you deserve. I imagine you agree with me on that. I gave you a pretty long one the session before this. Okay, so recognizing a linear equation, I'm sure you already know how to do that. Graphing a linear equation, I'm sure you already know that as well. And then a little review of equations whose graphs are parallel to one of the axes. So we're going to start with graphing this, which is a linear equation. How do I know it's linear? Because the power is 1. This power is 1. Right? We don't write the power when it's 1. We know that the power is 1. That's one of those unnecessary things to write. In the same way that we don't write 1y. We know the coefficient is 1. We don't bother to write it. I try to keep things simple and just put down the information that we actually need. So we want to determine 3 points, even though 2 points are all that we need. I think I've mentioned before why I think it's a good idea. It serves as a confirmation of your points. If you have only 2 and one of them was an error, you might not pick it up. But if you have 3 and one of them is an error, you will pick it up because they will not be collinear. We're going to try graphing this, and my favorite points to use would be 0 in the center. And just so that we do not have points close together, we have points that are further apart. Let's choose -3 and a +3. All right, when x is 0, this becomes 0, and my y is -2. When x is -3, this becomes -6, I get -8. When x is 3, this becomes 6, and I have 4. Well, based upon these 3 points, I better make my scale. Here's my x, here's my y, and I actually want to try negating this. So I'm choosing a white pen. Get rid of that. Remember, we're only going to put an arrow on the positive direction. Okay, so this I'll mark as 10, and this I'll mark as 10. What does that tell us? That each of these grids is 2 by 2. My 0, 0x, and -2y. So I'm right here. There. So I've done this one. Then I'm going to do -3, which would be 2, 4 right here. -3. And -8, which would take me right down to here. From that point. Now +3, which would take me to right here, and I'm going to go up 4, so put that right there. I'm going to try drawing a straight line, and try drawing it. I think I've got a straight line with the right slope, but it isn't exactly in the right location. So let me move it over just a tiny bit. So it goes right through those points. That looks pretty good, doesn't it? And I probably should put an arrows on either end there. Okay? So there's the graph of y equals 2x minus 2. By choosing points that were further apart, I was able to get a more accurate drawing. Let's try graphing this one. 5x plus 3y equals 1. Now, there are a couple ways I can go about this. I could, and I think I will right now, take a look at this in terms of the y-intercept and the x-intercept. And I'm going to assume that this is 5 and this is 5. So we will be using 1 by 1 grids. The y-intercept is the value of y when x equals 0. Okay, when x equals 0, this becomes 3y equals 1, and we can say y equals 1/3. So when x is equal to 0, y is equal to 1/3. I can plot that point. X is equal to 0, y is equal to 1/3. Put it right about there. That'd be about 1/3, wouldn't it? There's 1. That's 1/2. That's about 1/3. The other point I could do is my x-intercept. What's the value of x when y is equal to 0? When y is equal to 0. That would be 5x equals 1, or x equals 1/5. So x, when y is 0 right here along the x-axis, that's 1/5. Now, this is an example of points being way too close together, wouldn't you say? One-fifth. X is 1/5 when y is 0. This is not easy to graph. Let's get a lot more space. So let's make this 3, or -3, and this 1/3, and figure out what that would be. When this is -3, we get -15. So we can say 3y equals 16, or y equals, because I added 15 to both sides, y equals 16 over 3, which we would know is 5 1/3, right? 5 1/3, a positive 5 1/3, when x is a -3. -3, and it's going to be 5 1/3. So right about here. Now we start to get some good space, right? Make it easier to do that line. And the other one I wanted to try was a value of 3, which would be 15 equals 1. 3y equals, now I'm going to subtract 15 from both sides, so I'll have 14. So in this case, when x is 3, y is going to be 14/3, otherwise known as 4 2/3. Is that correct? So, oh, a negative. It's kind of important. A -4 2/3. So x is 3, takes me to here, and then I go -4 2/3, which takes me right to here. Now I have a really good basis for drawing a line, don't I? Get rid of that. So I can draw my line from here to here, and it looks very good. All right, let's see what we've done. We found the y-intercept, which was, excuse me, right here when x is equal to 0. Maybe I should color this for you. The y-intercept, that's the value when x is equal to 0. And we plotted it, didn't we? Where is it? It's right here. And then we found the x-intercept. That's the value of x when y is equal to 0. So that was 1/5. Remember this one. And we plotted that as well. But when we plotted it, we said, wow, those are really close together, and how am I going to be sure I'm getting my line to look the way it should? So we added a couple other points. It looks really beautiful now. Beautiful, beautiful. Graphs of linear equations. We're going to try a couple here. Now, one of the things you notice is we've got a negative slope and negative slope. Let me back up a moment. On this, I didn't mention it, but I actually converted this earlier to the slope. This is the slope intercept form, which I love, and a lot of my students like this one too, because when you have it in this form, it becomes obvious that you're going to have a line which is dropping as you move from left to right. The negative means it's dropping. And it tells you just where the line is going to cross the y-axis at 1/3. So it's a very useful slope-intercept form. These are both in the slope-intercept form, so we know the slope on this one is -2. And the slope on this one is also -2. The y-intercept on this one is 0, right? There's nothing being added here. And the y-intercept on this one is 1. Now the form I'm talking about, slope-intercept, is always like this. Y equals slope, represented by m, times x, that's my slope, plus b, that's my y-intercept. Knowing those two things, I can graph these without having to even do this t-chart. Let me show you how I do that. I think I'll go for a little bit bigger dot here. For what color have I got? Check it out. Oh, it's red. I don't even want red. I want blue. Oh, I like to have a nice strong dot here. So the first, I'm going to recommend this to you. The first thing you graph should be your y-intercept. In this case, my y-intercept is a +1 right here. The next thing you should graph is where you get to when you pay attention to the slope. Remember that the slope is always rise over run. Or, another way to think about it, the change in your vertical over the change in your horizontal. In this case, for this one, our slope is -2 over 1. How am I going to represent that here? I'm going to say I'm going over 1 and then I'm going down 2. Or I could look at it this way. I'm going down 2 and then over 1. And that would put my next point right there. And I could draw my line at this point. Now I know I've told you it's a good idea to, let me actually draw a line. And I'll even put it in the right color. I've told you it's a good idea to have more than one point, more than 2 points. And I'm not doing that here, just to save you some time. So this is y equals negative 2x plus 1. It's crossing at 1 and it's got a slope of down 2 over 1, negative 2. Now we're going to graph this next one, which has exactly the same slope. I'm going to do this in green, make it easier for us to follow what's happening. The y-intercept in this case is 0. There's nothing here. That means it's at 0. And the slope, it's down 2 over 1. Let's try drawing that line. Alright, it's going to look kind of similar. See if I can get it just where it needs to be. Alright, they have the same slope. What do you notice about them? You notice anything special about them? Well, remember this symbol here from your geometry course? That's saying that these are parallel, which leads right into the last part of our lesson, where we're going to talk about lines that are parallel, not to one another like they are here. These are parallel to one another, but parallel to one of the axes. If we graph y equals 1, it's going to look just like this. It is a horizontal line, agreed? Horizontal. And it is parallel to which axis? The x. I probably should have written it. X, y, this is 5, and this is 5. And then when I do x equals 1, too bad I can't draw a straight line, it's a vertical line. And it is parallel to the y-axis. See you back in class.